All right. Aisha wrote the following explanation about this relationship in the triangle. Okay? She said, I can see that TVY is congruent to UV or YVU. I can see that VUX is congruent to XUT, and UZT is congruent to ZTV because TZ, UT, and UX bisect opposite sides of each vertex. So all those are concurrent because of that. Now, are the angles marked in there or not? No, the angles are not marked. What's marked is the sides. So if angles are not marked, can you assume that they're congruent? And the answer is no. Okay, so she's assuming things are congruent that really aren't congruent. So what we're going to look at today are altitudes and medians. Altitudes and medians. So an altitude is a perpendicular segment from the vertex of the triangle to the line containing the side opposite the vertex. Okay? So an altitude could be inside the triangle, or it could be outside the triangle, or it could be on the triangle. Okay, and we'll look at those situations here in a little bit. But an altitude is a perpendicular segment from the vertex of the triangle to the line containing the opposite side of the triangle. So it goes from the vertex to the opposite side, and it's perpendicular to the opposite side. A median of a triangle is a segment that has endpoints at the vertex and the midpoint of the opposite side. So it goes from the vertex to the midpoint of the opposite side of the triangle. Okay. So A is an altitude and it's perpendicular to the opposite side DC. BD is a median because it bisects the opposite side AC. Medians are all concurrent. They all cross each other at the same point called the centroid. So the centroid is a point of concurrency of three medians of a triangle. The centroid is point of concurrency of three medians. Okay, the next important thing about medians. The median is AD. AG is 2/3 of the length of AD, okay? Because it hits the point of concurrency 2/3 away along from the vertex to the opposite side. So if this part, AG, is 2/3 of the whole thing, how long is GD compared to the whole thing? 1/3 of the whole thing. If this is 2/3 and this is 1/3, how many times longer is this than this? 2 times longer. If this is 2/3 and this is 1/3, this is twice as long as this. So, if on our triangle this was 6, how long would AG be? 12. Okay. So then how long is the whole thing? What's 6 plus 12? 18. Is 12 2/3 of 18? Is 12 2/3 of 18? Yes. Sure is. Okay. So that's some of the questions that we'll have on this. So if JQ is 18, how long is JN? Well, if this is 18, is that the 2/3 part or the 1/3 part? 2/3. So how long is QN? 9, because it's on the 1/3 part, because the 2/3 part is twice as long as the 1/3 part. So how long is JN, the whole thing? How long is the whole thing? 27. Okay, the whole thing is 27. An artist wants to balance a triangular piece of wood at a single point on a triangle that is parallel to the ground. Where should he balance the triangle? Well, the triangle is balanced at the center of gravity, which is the centroid of the triangle. How do we find the centroid? It's where the what intersect? What's the magic word? What's on your vocabulary sheet? The centroid is where the point of concurrency of medians. So it's where all the medians intersect. So what we have to do is draw the medians of each side of the triangle. Where those intersect, that's where you should put the triangle on top of that tiny little point. If it goes right on there, it should balance at a place that is parallel to the floor. Okay. So that person drew a right triangle of 15, 20, and 25 centimeters. Determine the centroid. Well, if this is 20, each of these are 10 and 10. Okay. If this is 15, each of these are 7.5 and 7.5. So what they did is drew from here across to there and there across to there. And this is the location of the centroid. Okay, altitudes. All the altitudes will cross at a certain point, and that point is called the orthocenter. The orthocenter is a point in concurrency of altitudes. The orthocenter is a point in concurrency of altitudes. So where 3 altitudes intersect, that's the point of concurrency. All right. So looking at this, since this is a 103-degree angle, it's a what type of triangle? Obtuse. Where is the orthocenter on this black triangle? Inside, outside, or on it? Outside of it. Outside of it. The orthocenter is outside when we have an obtuse angle. Here's a 90-degree angle, so it's a right triangle. Where's the orthocenter on this one? Not on the hypotenuse, on the right angle. It's right on the right angle. The where the three altitudes meet will be right at the right angle on a right triangle. This one is an acute triangle. Where's the orthocenter of an acute triangle? Inside. So it's just like a circumcenter. A circumcenter on an obtuse triangle is on the outside, on a right triangle is on the triangle, and on an acute triangle, it's inside. Okay. Orthocenters. How do we find the orthocenter? Well, we have to draw the altitude. So to draw an altitude, we have to figure out what the slope of the opposite line is. Okay, this is the hardest part of the chapter right here, is we got to figure out what the slope of the opposite line is and draw a perpendicular to that. Okay, so from 0, 0 to 10, 5, what's the slope going to be? What's my rise from 0, 0 to 10, 5? So KL has a slope of, we rise by 5, run to the right of 10. So it's 5 over 10, which is 1/2 is a slope. So KL will have a perpendicular slope of what? What's perpendicular to 1/2? No. Perpendicular is an opposite reciprocal. -2/1 or -2. So I have to go from M, the point that's not on that line, and go a slope of -2, which means I go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Okay, that's that altitude. Now I got to draw another altitude. So let's find the slope of Km. What's the slope of Km? I rise 12, run to the right of 3. So what's its slope? 12 over 3 is what? 4. So then the perpendicular to Km, what's its slope going to be? -1/4. Okay, so Km is here, so I have to use L to find it. So I go down 1 to the right 4. Well, that's not inside the triangle, so I got to go the other direction. Back 4 to the left 1. Back 4 to the left 1. It'll look like this. Where do they cross at? 6, 6 is where they cross. So you're going to have to draw a picture, a really good picture. You might want graph paper from the box. Draw out the triangle and then figure out slopes to figure out where the orthocenter is. Let's do that again. Okay. All right. First, let's find the slope of JL. What's the slope of JL? What's the rise? How far do I go up from 4 to 15? 11. What's my run to the right from 0 to 11? So what's the slope? 1. What's the slope of the perpendicular to JL? -1. Okay, -1, because it's opposite and it's reciprocal. So if JL is here, I go from K and I go -1. So I go back 1, up 1, back 1, up 1, back 1, up 1. So I go like this. There's one altitude. Okay. Now let's go the slope of KL. What's my rise from 0 to 15? 15. Okay. And then my run to the right from 6 to 11. 5. So the slope is 3. So what's the slope of the perpendicular to KL? -1/3. So we go down 1 to the right 3, or back 1, up 3. Oh, from here. So to the right 1, down 3. Ooh, that doesn't look right. Yeah. Down 1/3, to the right 1, down 3. To the right 1, down 3. That's not getting any closer. K, L. So I go from here to the right 1, down 3, to the right 1, down 3. So I got to go to the left 1, up 3. So they cross somewhere around here. Ooh, they didn't make it very nice on that problem. Because you're crossing somewhere right about there, which is like -1 and 4, 5, 6, 7. -1, 7. If that doesn't work very good, we could try the slope of JK. What's the slope of JK? It goes a slope, so it goes down 4 and to the right 6. So it's -4/6, which is -2/3. So the slope of the perpendicular of JK goes +3/2. So +3/2, we'd go up 3 to the right 2, but here we'd go down 3, 1, 2, 3 to the left 2, 1, 2, down 3, 1, 2, 3 to the left 2, 1, 2. That's where it should be, is right here at 3, 3. I don't know what I was doing wrong on this other one. So it should be more like 3, 3 is where they cross. Because I was going the wrong direction on this one. So the slope of this one, we went up 15 to the right 5, which was 3, -1/3. Yeah, that maybe the drawing was a little goofed up. All right, so you might need some graph paper, graph it out really good to figure out orthocenters. So your assignment, let me put it out there. And just one assignment today because we had a couple quizzes. Thursday, we'll take a quiz, and again, just do one assignment because we have Veterans Day in there, the Veterans Day program. On Thursday, we have a Veterans Day program, so we only have class for an hour, not 90 minutes.
Oh, well, only 30 less minutes.
What? Yes.